This is my casting board and patterns for the Shelley jack. You can see the 4 cast components of the jack. So this is the jack body. You can see this is important that the model of the jack is shown clearly on the finished product. It is actually the same as another model, but it is important that the LJ22 is clearly legible on the casting. You can see on the casting of the body we have the core prints at either end, and we have the core prints at either end. We have over here the top saddle of the jack, we have the pinion gear of the jack, and we have the crown wheel of the jack. These gear teeth are simply sand cast parts, and it's a sand cast finish on those teeth, and that's perfectly adequate for this application. I'll show you an assembly in a second here. So that is what one side of the casting patterns looks like. I'll just turn that over and you can see what the other side of the casting patterns look like. This has the brand showing that says Shelley on the side of the body of the jack. You can see again the core prints on either end. You can see the bottom cylindrical or the round parts of the crown gear, the crown wheel, and you can see the square drive part and the core prints for the other end of the pinion gear. There's the runners shown in between the components. So that's the other side of the casting pattern. Over here we have the core box, so we can make the cores of the jack body. We have a letter imprint on which side of the sand cavity that the pattern goes into, that the core box goes into. So the A must match the A on the cavity core box for the body of the jack. We've got the other core prints here for the where the gears go in the side of the body of the jack. And then this is the core prints, the core box for the pinion gear. So that's the components for casting up the jack. And then this is what the jack pretty much looks like all assembled. I'll see if I can take this apart with one hand so you can see how it goes together. This is the top saddle of the jack. It has a drilled and then broached round-ended rectangular hole in it. This is simply peened over the end of this shaft. It has a laser cut or stamped plate holding the pinion gear in the side. The pinion gear, just since I have it in my hand, it shows an internal square drive. You can see a detent. You can see the small holes in there for the detent for the spring-loaded balls that hold the drive handle. That's a 3/4 inch square hole in there. This core print, this core box may be making that hole a little undersized. So we'll have to look at this and see if it is making the hole undersized. We may have to alter or adjust the core box slightly so that a 3/4 inch hex drive or square drive can fit into that. These are a cast finish here. They've been machined on the outside. This is held in a 4-jaw chuck, and we get this as concentric as we can with the square drive. The most important thing is that it's concentric and in alignment with the gear on this end. so that this is running nice and straight for the gear engagement with the crown wheel. So when we're turning the pilot on the end, and we're turning the bore on here, and we're turning the smaller diameter here for the retaining plate, it's important that this is done on this axis. This is the body of the jack. This has been machined correspondingly. You can see it's got the, it's been bored there. It's been faced on this surface. It's been drilled and tapped so it can hold the screws for the plate on here. And it has been spot faced, and it has been drilled through to take the pinion, the pilot on the end of the pinion gear. Let me see if I can dismantle the jack. Again, I'm working one-handed, so forgive me here. These have got 2 screws. It's a 2-stage screw jack, and the screws are both a left-hand Acme thread screw. Excuse the interruption. I'm working one-handed, and I had to dismantle the jack so I could continue the video. So this is the crown wheel, the crown gear, and sand cast teeth with just a sand cast finish on them. It's been drilled through the middle of the gear. It's been tapped with the appropriate Acme thread. It's an 1 1/8" Acme thread. It has been counterbored on this side to allow the thrust bearing components to go in there, and like the pinion gear, the crown gear has to be set up very accurately on the gear surface before we machine this top surface and drill that through axially and concentric with the gear teeth. This is where the thrust bearing sits against the machined top surface of the jack body. So that has been machined off. The bottom of the jack has been machined off, and so these have been machined relative to each other on the height. And then the side of the jack for the crown wheel, we looked at that previously. That's been faced on this surface on the outside. It's been faced on here at the correct angle. It has been drilled and tapped for the screws for the retaining plate. And then again, the very accurate angle between the gears has been transferred through to the... So we're looking at the jack body. I think I mentioned previously the ridge that's cast on the inside of it. You can see there's a clip that wraps around the outside of the Acme thread, and that clip is to go either side of that ridge that's cast into the jack. So you can see how that works there. So when it turns in there, it's got a little bit of a drag on there where it's holding the bottom of the shaft. The thrust bearing on the inside of the crown wheel, that slides into there and rests on the top of the jack, and that's what takes the thrust, the axial thrust or the load on the jack on that thrust bearing. And that crown wheel is just driven by the pinion gear that comes in from the side. And that's about all there is to it.